How does your
influence.
background in complex systems and brain sciences influence your approach to developing AGI hardware at Simuli?
Very good question. So not only does it influence my approach to hardware, I mean, the whole reason that we wanted to make hardware and that we've partnered with people to help us make that hardware in the first place, is because I'm actually, I guess, I mean, David Hansen actually said this to me the other day, and I was like, that's actually accurate description. I'm a cognitive architecture scientist. That's what I've most studied and most well read in, I guess. That's what I think about most of the time is cognitive architecture, um, which probably makes a lot of sense listening to this.
Yeah.
um, so,
That's what you talk about a lot, really, when you're
yeah,
talking about AGI.
when David
That's
said
what
that, I
we're
was
talking
like,
about is the cognitive architecture. And it's really funny when you try to explain to people, that an LLM doesn't have all the pieces to be an AGI. It
right.
would have to connect to other things in the
How are you
cognitive
going?
architecture. And
Yeah,
people go cognitive architecture and they don't even, and it's not that
mind
hard of a
blows.
concept. Yeah, it's just how the things are fitting together to make the mind
Well, you gotta have things. That's the
process.
first part. You gotta have
Yeah.
different things. You can't just have
Reasoning,
gradient descent all
inferencing,
the way back, right?
sentences.
Yeah.
Yeah.
You gotta have them. I mean, what I'm really passionate about in our cognitive architecture, which is the recommendation architecture, which we have a prototype in Python now called Rearc. Um,
Okay.
we haven't released it yet because we want to make sure, we have to do tests. It's responsible when you build a cognitive architecture to thoroughly test it, make sure it's safe, then let people play with it, right?
What does it
Uh,
do?
it's just autonomous system, autonomous AI, right? So right now it's very, very primitive, very primitive. But we have a paper out there, or we released it last year, I think. It shows that, and it does not use hypervectors, right? So there's a couple points here. So yeah, so the rearc,
So wait,
which
when you're
is
testing it, just really quick, when you're testing it, what might be one of the tests, just so we can follow?
we're just trying to see how it makes decisions, right? We're trying to see what kind
Okay.
of perceptions it can take in, what outputs, if it when it's meant to be really multimodal architecture. So when you mix audio and sound, how does that interact in its internal thought process, right? And when it spits
Hmm.
out output, is that output kind? Is that output nice and safe, right? Or is that output biased towards some sort of thing we really don't want to see? But it's very
Mhm.
primitive at the moment. Yeah, it is primitive because it's the first prototype. All right, so you got to be patient for us to grow this thing up and build upon it, right? But that's what we started Simuli for, is to build out Rearc,
Oh,
to
okay.
be more efficient AI. And in order to really get some of the core new learning algorithms, we need hypervectors. That was my solution. Maybe there's someone has a different one. I found a solution. It's hypervectors, so that's what we're running with. And so we had to walk that stack all the way back through our product pipeline. So we have the compression hypervector stuff. How does data live? We have how does data move? That's the API. We have a very vague semblance of a prototype there. And then we have a full Python model of Rearc. And so these things all connect. And we're going to build all the way up to Rearc. And, we're not just building one direction, but they all work together, right? And so that, Grace, is the long-winded answer to your question, is that I think we're building the hardware because we need that for the type of architectures that can use resources more efficiently, which will
Mhm.
give rise to more general types of learning algorithms. That's exactly
Okay.
what we're doing.
So these are all kind of missing links
Yeah.
for AGI to occur. You know,
Well, so
these pieces that that you're adding
yeah,
are just things people have been talking about
things that can help.
and
So how
needing.
making data more efficient, the way it lives, that's something to help all of tech, right? Especially AGI because it needs to consume all of the information, right? And then the other missing link is like, okay, well, how do you actually compute more efficiently? How do you reduce the number of operations? And how do you not have massive emissions by just throwing like massive, you don't just have to use parallel compute. You can actually try to reduce your bloat code, reduce your emissions by using more effective hardware, right? So we've just borrowed from our cognitive architecture and made pieces of our cognitive architecture that rely on efficient resource use into kind of links that other people who are working on other forms of AGI, like Ben and Hyperon, SingularityNet, to AGI, like we're just trying to offer this up because we think these things are going to be important in any AGI, like you said, Lisa.